Now it's actually called Secure Connect Gateway. Sorry, it used to be Connect SRS, Secure Remote Services. Now you're going to hear more about Secure Connect. This is a feature that will let you enable a secure connection to our Dell EMC backend support service. Again, this is all optional. You don't necessarily need to enable this in your environment. This is the feature that can help to, for example, raise support tickets if it's needed, if there are some issues reported about hardware failures. This feature can work as either an embedded direct connectivity from your environment to Dell EMC servers, or you can get connected using a gateway. It all depends on your environment. The feature is not limited to VxRail only, but can work with any Dell EMC system. Hence, you need to choose between the two options. If you have a VxRail environment only, you would like to get connected, you can use the internal connectivity, which is part of the VxRail Manager VM. You just enable that, okay? And that's going to get you connected directly. And that's connect directly, okay? If you have multiple systems and you want them to be connected, there is another design of the same feature, which means you will actually need to deploy a virtual appliance that's going to act as a secure gateway to connect multiple systems. For example, you have, let's say, PowerStore, you have OEME, you have, I don't know, multiple other systems, PowerMax maybe. You want to connect all this to our servers, you can do that using secure gateway. One of the benefits of enabling this feature is basically the monitoring of your environment, and if you have multiple clusters spread across multiple geographically separated locations, you can connect all these environments and have a single dashboard in the form of a product called Cloud IQ. This is a cloud solution from Dell EMC. So see if you have, for instance, one data center in Casablanca, another one in Paris, another one in Austin, Texas, another one in somewhere in Asia. You can connect all of them to Dell EMC backend support servers, and then through Cloud IQ interface, you can monitor the stages, storage usage, and basic stuff using a single interface. If you want to orchestrate, for example, a software upgrade for all these environments, at the same time, Cloud IQ will require a license for that. So here in these few slides, just you can see a high-level view of how Secure Gateway gets connected or enabled in your environment. If you have a Secure Gateway, you need to add its IP address plus the port that's going to be used, and then hit connect. After that, yeah, you get to choose which level of access you'd like to enable. So more details are available in a solve procedure that describes exactly how you can use this feature in your environment. Node will have certain number of disks attached to it. For example, here, let's imagine that we have 2 disks in each one of the 4 nodes. I'm going to get into details in a moment. Okay, so let's imagine that each one of these disks is a 1 terabyte disk. Okay, so the software will take all these disks together. Okay, can you guys still hear me? Looks like everything is frozen.
Yeah, can hear you okay.
Well, this is strange. What's going on? The mouse just stopped. Okay. So I was saying that basically the software will group all these nodes or these disks together. Let me just change the mapping. Okay. In order to create one storage, so all these disks will contribute to the storage. It's going to be one single big storage, which is our vSAN data store. In this particular case, since each node is participating with 2 terabytes and we have 8 of them, well, basically the raw capacity is going to be 8 terabyte, but you'll never have 8 terabyte because there are a lot of things that will consume storage from your vSAN data store. Okay? So, how are disks managed in a vSAN environment? Please keep in mind that everything I will explain is actually based on what's called now as OSA architecture. With the introduction of the new vSAN architecture, VMware just decided to name or rename the old architecture, the original one, as simply original storage architecture. The other architecture is called ESA, Express Storage Architecture. You can build it only using version 8 with a very specific hardware and requirements. So it's not really something widely used for the moment, maybe something you would consider for the future. So I think that all of you are using OSA now, so everything I will explain is based on OSA. Okay, so each node will have a certain number of disks. These disks will be grouped together to form something called simply a disk group. Okay, this group will have one cache. This is going to be called the cache tier. And we're going to have one or more disks used for what's called the capacity tier. Okay, so this is going to be our capacity tier. Okay, so if the nodes are made of cache, which is SSD, and by the way, cache is always SSD. Okay, it's always SSD and it's always one disk and one and only one disk. Okay, so if cache and capacity are both SSD, we call the node all flash node. Okay, now if capacity is made of hard drives, we call the node hybrid. Okay, that's how it works. In a single cluster, you can't mix hybrid with all flash. That's not possible. For instance, the S series from the VxRail family of products, S stands for storage, are hybrid only. These are nodes. By the way, these are the only nodes that can use 3.5-inch drives. And 3.5-inch drives are all hard drives. This is the S series are an option for customers looking for a huge amount of storage in a reasonable price. Because one of the benefits of using hybrid, if you're not concerned too much about performance, is that you can really get really big capacities in a reasonable price. Okay, some nodes will be available with one disk group only. Some nodes can support up to 4 disk groups. I don't really know what's the maximum supported now. I don't have numbers in mind or specification sheet for every and single every single VxRail node. It used to be 4 disk groups maximum supported in VxRail. That used to be the maximum. I'm not really sure for the moment what's the maximum supported. vSAN wise, if you are talking about vSAN in general, the maximum number of disk groups that can be supported in a single node is 5. The maximum number of disks supported per disk group of the capacity tier is actually 7. So if you do the maths, 7 by 5, that's 35 plus 5 cache disks, that's 40. You need a node that supports 40 slots. That's for vSAN. Since here we're talking VxRail, you're going to need to have a look at what's supported basically by VxRail nodes. If the node supports a certain number of disk groups, for example, if the nodes you are managing in your environment support 4 disk groups, it doesn't necessarily mean that you're going to purchase them from day one with 4 disk groups. You may start with a limited number of disk groups, maybe 2 disk groups, and then later you have the possibility to scale up, which means you can add additional disks to the existing disk groups, or you can enable additional disk groups by adding at least 1 cache and a certain number of capacity disks. There are different ways of adding resources to your VxRail environment. We'll talk about that later. But just to give you an idea, if you want to scale up, which means adding resources to the existing nodes, you can basically add additional capacity disks to the existing disk groups. For instance, your node supports a maximum of 5 capacity drives per disk group. You only have 3. You have room for adding 2 additional capacity drives in each disk group. If you are running out of slots for each disk group, you can enable additional disk groups by adding 1 cache and a certain number of drives. There is also another option that most customers do not do. You can simply replace the existing disks by adding disks with larger capacities. Okay, so these are the different options. In VxRail, we always add resources in a very balanced way, so you can get the best possible performance from your environment. This means if you have the possibility to have the same disk numbers per disk group, same capacity, same specifications, that's perfect. Okay. If you are wondering, well, should I go with a large number of disk groups or a limited number of disk groups with higher number of disks per disk group? The best approach is to have the maximum number of disk groups possible enabled in your environment. The thing is, more disk groups means more cache, and more cache means more performance. Okay? So first of all, now that we learned that disks will be managed in this way by building disk groups, etc. So let's see how we can read and write to each one of the 2 architectures, all flash and hybrid. Before we continue, any questions about what I explained until now, especially for beginners in vSAN? Any questions? Okay, no questions. Okay, so if you have any, feel free to ask. All right, let's take a look at how data is read and written from an all-flash environment. As a reminder, all-flash is made of exclusively 100% of SSDs. So for all-flash systems, this is cache, this is capacity. So for all-flash systems, 100% of the cache tier is used for writes. Okay? Everything that comes from the VMs will land here in the cache tier. So the cache tier in all flash is is exclusively dedicated to absorb all the writes. So the VMs will not be impacted from a performance point of view. In the vSAN environment, in OSA, we do something called destage. This means that we're going to absorb all the writes, and then in the back end, we will move the data from the cache to their final destination, which is the capacity drives. vSAN will monitor storage usage in cache disks and move data whenever it's required. For reads, 100% of reads are served from the capacity tier. Okay. From a read point of view, reading from SSDs will always give you decent performance. Okay. Because the most challenging in storage is always writing data, not reading the data, especially when it comes to SSDs. SSDs are really good in terms of read performance, regardless of the type of SSDs. What I'm talking about here is valid for SATA SSDs, SAS SSDs, or even NVMe. And speaking of types of disks, in VxRail, we have different options available. You can build an extreme performance by having the cache tier in the form of Intel Optane, which is using the 3D point type of flash or non-memory. And for the capacity drives, you can use NVMe drives. Okay, so this is reads and writes. Now for hybrid, well, it's another story. Hybrid, as you know, capacity are hard drives. And cache is SSD. This is cache. This is capacity again. The problem here is when you don't find, you don't want to read from the capacity drive. So what we're going to do by default here is we will split that 100% of cache to reads and writes. So 70% for reads and 30% for writes. Okay? So that's how it works. When a write comes to the cache, similar to all flash, we're going to destage. So for writes, we're going to hit the 30%. Then vSAN will proceed and move data accordingly whenever it's needed. Now for reads, here's what's going to happen. When there is a read request, we will look at the 70% of the cache. If that data is not available, we will read from the capacity, which will slightly impact the performance. There are techniques that can help to improve this. For example, when you are using RAID 1, we have 2 copies. I'm going to get into more details later, placed in 2 different hosts. This is valid for all flash or hybrid. The read here will come 50% from the first copy and 50% from the second copy. Okay. So we're going to try to read from the 70%. If data is there, that's perfect. If not, we will read from the capacity and make an extra copy, place it in the 70%, and then avoid reading from capacity next time. The data that should be placed in the 70% read is actually the most frequently used data. Okay. Questions about reads and writes? No questions? Okay. Now, how do we read and write, or what is the data path from the VM down to the disks? Okay, just going to talk about this briefly and then we will have a short break. So let's imagine that I have a VM running here. Okay, this is called VM1. In a vSAN environment, the VM can be running from a compute point of view on host number 4. And its data is placed into the first 3 hosts. There is no rule that, by default, requires the VM to be running within the same host from a compute and storage point of view. That's not mandatory. And it will have zero impact on the performance. I mean, having the VM running on host 4, consuming CPU and memory from host 4, and having its data components placed in the first 3 hosts, it's not going to impact the performance of the VM. Okay. So, how does it work? In my VM, I have a disk allocated to it, maybe 100 gigabyte disk. So the operating system will write into that disk. The OS will send them some data and write that to the disk. The OS or application it is running. Okay. So from operating system, from a guest OS point of view, that's the end of the story. Because for the OS or the application, the virtual disk here is something that smells like a disk and looks like a disk. So for it, doesn't really know, it's all virtual. That data will hit the VM kernel or the kernel of ESXi, on which we have enabled vSAN. So it's going to look at it and say, hey, this looks like some data for vSAN. We have a network here that acts as the vSAN network, okay, to connect all the nodes together. So when we detect that the data is actually something for vSAN, well, the VM kernel will simply look at what's called storage policy assigned to this object. And the storage policy will let vSAN know exactly where the data should be copied. All right? And the distribution of the data will go through the vSAN network. So maybe it's RAID 1, maybe it's RAID 5. You have different options available. Make sense? Questions? Okay, so this is the physical view. I already covered this morning. The host physical view, the disk, alerts, actions. Regarding the disks, if it's an SSD, normally we should monitor the remaining write endurance for the SSD. So if it reaches 30% of remaining life, you get a warning. 20% you get critical error, and 10% you get fatal error. At the end, the SSD will become read-only. So that's going to give you enough time to replace the SSD.